Hello, good morning, everyone. I'm Josh Thurman. I'm co-founder and I organize our open source efforts. And I'm here with one of my key team members, Adam Volworth, who's our DevOps architect.
Hi, hello. Looking forward to demonstrating how to install Uffizzi on Kubernetes using Helm, configuring it, and getting it working with a GitHub action and the CLI also.
Awesome. So welcome to our workshop. This is adding CP or continuous previews to your CI/CD. And continuous previews are automated on-demand environments. We're going to be using Uffizzi Open Source, GitHub Actions for today's workshop, although you can use any CI/CD provider, Docker Compose to define your application, and Kubernetes to run your application workloads. You'll need a Kubernetes cluster. We've tested on GKE, AKS, and EKS. You should be able to do this on-prem. You need the Helm CLI installed locally. And then just generally, expectation is working knowledge of Kubernetes and Docker Compose, working knowledge of CI/CD pipelines, and basic knowledge of Helm.
I'll mention if you have a Google Cloud account, that's probably the easiest way to create a Kubernetes cluster that you can use for this. If you have an AWS account or an Azure account that you really like, then you can set up Kubernetes on there. It's just a few extra steps for the networking and IAM stuff. We're going to next work through installing Uffizzi using a Helm chart into a Kubernetes cluster. So if you're not familiar, Helm is sort of a package manager for Kubernetes. It uses some values you provide to render templates for Kubernetes resources and then install those resources, specifies them in the cluster. And so here's the documentation we're going to be working through next. This Helm chart does require a Kubernetes cluster. It will probably work on a Kubernetes 1.19 or newer, but we've only tested it on Kubernetes 1.21 through 1.23. The API versions, especially the ingress resource, are the limiting factor there. The cluster must be capable of provisioning ingress resources that obtain public IP addresses and or host names. And this is going to be the limitation for running Kubernetes on your workstation, like with Minikube. So we would recommend that you use Google Kubernetes Engine or Amazon Elastic Kubernetes or Azure Kubernetes. Those are the three platforms that we've tested on the most. If you are confident about setting up your own Kubernetes cluster that has public networking, you can certainly try Uffizzi on there. Let us know how that goes. We're pretty sure that'll work. This Helm chart does have some dependencies. It depends on the Uffizzi controller, which is an intermediary process that's written in Golang to talk natively to the Kubernetes API, and that runs inside the cluster. Having that as an intermediary provides some security because the web API does not have direct access to the Kubernetes master API. It's intermediated by the controller. And the controller has its own dependencies of cert manager and ingress nginx, which are Kubernetes packages. If you happen to have cert manager installed already, then you'll have its custom resource definitions installed. The web app depends on Postgres and Redis, and I've selected the popular Bitnami Helm charts to install Postgres and Redis in a nearly production-ready way. But for this workshop, we expect you're installing this to an empty cluster, so there's not going to be any conflicts. This Helm chart does require integration with your DNS records. That's part of what we're going to be walking through. So you'll need to set up some values in a values file for your Helm chart installation. And when installing Uffizzi, it's important to generate strong passwords. And we're going to start that now. So I'm editing an example values file. And you can read more about values files in the Helm documentation. But when Helm renders these templates of Kubernetes resources, it needs some values that you provide. The most important ones are going to be the DNS records. And you can see the example Helm file here that I should probably just copy into a new file. So I'm using Vim as an editor. So I've copied the example Helm values into a new file. I'm going to change some of the passwords. We're going to change some of the host names. This will need to be a host name that you control, meaning you control the DNS records for, so that you have ownership of. So we're going to find and replace for all the host names here. And then finally, an email for the certificates. One of the extra values that Uffizzi provides is it will obtain a certificate for every preview, every continuous preview that you deploy. And it does that by default through Let's Encrypt. So I'm going to use my personal email here. Let's Encrypt is happy to provision these certificates to anybody. It just needs an email to know who's accountable. So now we have a values file that we can use. In this example, I'm going to use AWS. If you're connecting a Google Kubernetes engine cluster, you'll run a gcloud command. Here we use an AWS. If you're running connected to an Azure cluster, there's, I think, an AZ command. So that's just updated. I won't show you the contents of that. That's kind of secret. But if you run a command like this, it'll update it so that when you run kubectl, I think version, it'll connect to the cluster and tell you what version it is. This is EKS, so it's version 1.22. So now we're going to run Helm. I think that we probably have Uffizzi installed here. It helps if you spell it right. Okay. Yeah, Josh has already published a release of the Helm chart, but I'll show you how it works. The way you'll want to do it is first add our Helm repository. So I've already done that, but this command in the documentation tells your local Helm installation where to find the Uffizzi app chart, so that when you next run the command to install it, to publish a release, that should work. So I'm going to modify this. So we're running Helm install. My Uffizzi app is the name of the release. Let's change the name of that there. Uffizzi-app/Uffizzi-app is the name of the Helm chart repository and then the name of the chart itself. The -- values option tells Helm which values file we want to use, and it's going to be the file name that we just edited. We want to put this in a separate Kubernetes namespace to keep it separate from the Helm chart that we've already deployed there. And we do need to tell it to create the namespace, unless you want to create it yourself, but you probably want Helm to create the namespace for you, so you need the create namespace option. I actually expect this will fail because of the custom resource definitions. Okay. The custom resources definitions for Cert Manager already exist. But if you install it to an empty cluster, that would work. And I hope that you will give that a shot. So instead, we're going to use the other install that we've already installed there. I'm going to use a utility called K9s to look at what we've installed. So we're looking in the default namespace. This is looking at certificates, but let's look. When Helm runs, it renders templates for many Kubernetes resources, including all these deployments. And it takes the values you set to render all these, get everything working. The next thing you'll want to do once you're installed is look at the ingresses. So here's the YAML representation of the ingress for the main API. If you're on Google or Azure, the load balancer status is going to be an IP address. On AWS, this is a host name. And so next we need to add our DNS records to point to this. And I'm going to stop sharing for just a moment to get into our DNS. We use GoDaddy for our DNS provider for this domain. For other domains, we use Google and other DNS providers. But your own DNS provider is going to probably look different, but the records you create are going to be the same. Because we're on AWS and we're given a host name, we're going to create CNAME records. The name of the record is going to be, for example, in this example, it's DevOps Pro Europe .uffizzicloud.com, and then the data is going to be the host name you get from the ingress. You'll also want to create the wildcard record, so *.devopsproeurope22, and then the same value. And once you've created those DNS records, you can confirm them. The asterisk or the star at the beginning of the wildcard record means that any host name that ends in that domain will resolve to the same. So I can do host foo.devopsproeurope.uffizzicloud.com, and whatever value I put at the beginning here is going to resolve there. And this will be important once you're creating continuous previews and setting up new environments, new Kubernetes ingresses. You all want them to all come into that same Nginx load balancer. And so we're setting up our DNS records. We're using the utility K9s to look at Kubernetes resources, although you can use kubecontrol. Maybe I should demonstrate Kube. You can test that your DNS records and everything else is set up correctly by getting the certificates, making sure the ready status is true. They'll become ready after your DNS records are set up. And sometimes it takes a while for DNS records to propagate, especially if you're on AWS, that's what I found. So it may take 15 to 30 minutes, but eventually cert managers should obtain those certificates. Now you notice those host names are different from the ones that I tested, but we added those last week. You can test that this is all up by making an HTTPS request. Yeah. You'll get a 404 page at the root there, but if curl doesn't give you any errors, then that worked. You can run a Helm command. This is going to list all the installed releases. And I do encourage you to read more of the Helm documentation because this is just a very brief overview of how to use Helm. We can list our ingresses with kubecontrol that we've already done. And so set up our DNS users.
So at this phase, we have installed, so we have a Kubernetes cluster. For this demo, we're using EKS. And then Adam, you've installed via Helm, Uffizzi app and its dependencies. And so then our next step is we're going to set up the GitHub actions to make this all automated based on pull requests.
So I've just linked to this repository in the chat. This is an example web application. This is an example you might have seen before. It's published by, I think, Docker. We define 4 different containers, 3 application containers, and a load balancer. And more interestingly, in the .github directory, there are several pipelines defined. But for our purposes, we're going to fork this repository, and I recommend that you all fork this repository as well. Now I'm going to clone it onto my personal machine here. Okay, I'm on the main branch of my fork here. And we're going to, as you all want to do, we're going to edit the workflows to work with the Uffizzi installation that we just set up. Starting with the create preview environment, because that's probably the most interesting one. So if you haven't worked with GitHub Actions before, this is a YAML definition for a pipeline. It has a name, of course. I forgot the and so the on stanza defines which events are going to trigger or start this workflow. We want this create workflow to run whenever there are pushes to the main branch or the master or staging QA branch. That will build and push the images. More importantly, we want this workflow to run when we open or reopen a pull request. The overall goal is so that when you open a pull request on GitHub, after you build the images, you can deploy those images on Uffizzi and then get a link to that deployment so that you can look at the topic of your pull request by itself in isolation before it's merged with anyone else's code. Then after the pull request is open, when you push more commits to that branch, we want to update the existing deployment so that the Uffizzi preview will get your new code that you just pushed at the same URL so that your stakeholders and everyone else can keep looking at that same URL. And then when you close or merge the pull request, we want to destroy the environment. So this file defines the first part of that, which is creating the new preview environment. Every workflow is a series of jobs. So this workflow is going to have the first 4 jobs of building each container. This job going to first log into Docker Hub, and it checks out the Git repository, which is the example repository we're working on here. It sets up the tags that we're going to use for the images in the Docker metadata action, which, by the way, is a really great GitHub action. It does a lot of stuff for you. This is the name of the repository on Docker Hub that we're going to be pushing to. So you'll want to change that to your own, like that. So make sure to do that on your own workflows. And then the last step is going to build the Docker image and push it the repository that is defined up above. Notice the context here, it's going to build using the Docker file and files within the .vote directory. So there's a load balancer image, a vote image, a worker image, and then the next 3 jobs are very similar. So the first 4 jobs are going to build Docker images and push them to Docker Hub. The last job is the one that we're really here for. The deploy Uffizzi preview job is going to wait until those first 4 jobs finish building the container images. And after that's done, if this is a pull request, we're going to create a Uffizzi preview. The first step is it checks out the Git repository. Then it's going to render a compose file. So we'll take a look at that. This sets up some environment variables using the output of the previous 4 jobs. So it knows what image name to use. And then this file will take the template YAML file and use the environment variables set here to render a new Docker Compose file. And then it also it outputs to your build log the contents of that rendered template. So let's look at the template. If you're familiar with Docker Compose, you know that you define a series of services, which are containers generally. And we have added our own extension here. This X dash means that this is an extension to the Docker Compose syntax. So this is still a valid Docker Compose file. This is documented on our Uffizzi documentation site. And it's the extra thing you need for Uffizzi, which is telling our load balancer which of these containers you want to direct the traffic to. In this case, we want to direct it to the load balancer container on port 8080. You'll define your other containers here. This particular application wants a Redis container, a Postgres container, and you need to define a user and password so that Postgres will start up and you can connect to it. The worker container, result, vote, and the load balancer. And these are the substitutions for the environment variables that we saw in the build job. Just like in Docker Compose, on Easy, you can specify your memory resources and any environment variables. And you can specify most of the Docker Compose syntax on Uffizzi. We support it and translate it into Kubernetes. That's the template, and it gets rendered. So I was looking at the job workflow here. So once we have a rendered Docker Compose file, then we're going to deploy the preview using it. And this is the Uffizzi preview action that we publish. So the compose file here needs to match, the output here, and the username is what you'll want to change. The server is going to be the same server you use to run the Uffizzi login command. The same project name, and you'll need to set up a GitHub secret for your Uffizzi password. Let's go ahead and do that now. So this is inside my fork. I'm going to go to settings. I want to set up a Uffizzi password here. I'll briefly stop sharing, but here in the settings for the repositories where you set up your secrets for your actions. So now I've added 3 secrets: my Docker Hub username, Docker Hub passport, and the Uffizzi password. Those are the values it's going to substitute in there. The next step just checks the outputs. If the preview action was successful, it's going to output a URL where you can access that preview at. And then the next step is going to use a curl image. We're going to make an HTTP request to the URL that we get from the preview to make sure that we get a valid HTTP response. If this is a pull request, we also want to publish the URL of the preview as a comment on the pull request. And if you want other ways to notify your stakeholders, then you can add Slack notifications, IRC, email, whatever you want to do with that URL. So I think that's all you'll need to update. You want to change the Docker image to be a repository that you control, that you have access to. And then you need to change some of the values for the preview action here. So I'm previewing here the changes that I've made to this workflow pipeline definition. So we can show a change to the application itself. So on the main branch here, we have an example branch with change to the application. I'm going to update it with the main branch here. Yeah, so it'll have the new workflows. So you can see the differences between this branch and the main branch are just a background color or something and some logic so that if somebody votes for dogs, then it'll apply that vote twice, which means dogs are going to get twice as many votes as they should, right? Because dogs are better, they should get all the votes. So I'm creating a pull request to pull the double dogs branch into the main branch. We can see the same differences on both halves of my screen here. And once we create the pull request, our workflow is going to start. It should finish in about 90 seconds. So that's successfully deployed. And notice the right hand here is white instead of green. That's one of the two changes that we made. And it takes another minute for the voting part to come up. But when it does come up, when we vote, I guess it'd be hard to see that you're voting twice. Unless someone also voted for cats, but every vote for dogs would count twice. So now in this example, you'd share this URL with your stakeholders. They see it on the GitHub comment, or they get it in Slack, or you just send the link, and then they can see the feature in isolation by itself in its own environment before it gets merged in with everyone else's code. But the stakeholders have decided they don't want this change. They don't want dogs to be voting twice. So we're going to close this pull request. Okay, it's closed. Now it's going to run the GitHub action to delete it. And that does not take very long at all. So yeah, if we refresh it over here, it's no longer available. Yeah, it goes HTTP 503 and then 404 as it gets unconfigured in the load balancer. Yes, that closes the loop.
If you have future questions about related to Uffizzi and the open source, feel free to, we have a Uffizzi user Slack group. You can find that at uffizzi.com. Feel free to join.